Alright, Harmony Science Academy students in AP Cal, let's go ahead and get into today's material. The learning topic is differentials, plural differentials. Of course, go ahead and set up your virtual notebooks, and let's go ahead and get into the essentials, okay? Of course, reading the formalities of the section are very important, but let's go ahead and see if we can reduce it to practical terms, okay? So you will be asked to do two things. Now, in terms of the calculus, I think that's the rich part, but right, the differentiation. So we're going to get more practice, but the concept I think is pretty straightforward. Okay. So in very informal ways, we know that dy dx is essentially doing what? It's differentiating some function. Okay. Now this is pretty much the derivative, right, of f of x. However, if we look at these two specifically, they have a name, right? This is the differential of y, the differential x. So, well, in very informally, okay? But as far as d of x, that's pretty standard, okay? The differential x. But the differential y, if we wanted to solve for it, what we can do is we can simply multiply both sides by this dx, okay? And we would have this right here. Okay, so here we're dealing with differentiation. Here we have the differential of y. Okay, so this is important because as we definitely move on into the AP exam, it's the context, right? When you read a context, you read differential, you don't want to be tripped up. Okay, they're definitely related. So let's go ahead and get into it. This first part's very easy. Again, the lesson's going to be pretty basic. We're going to get more opportunities to work on differentiation. So let's go ahead and what does it ask? For each problem, find the differential dy. Okay. So very easily what we can do here is differentiate y in terms of x. And we know we're going to go ahead and get what? Okay. Or I guess we can go a little faster. Alright, we get negative 2x minus 2. So we've differentiated y, but since they're asking us for the differential y, okay, we simply what? Multiply by dx. So we have the differential y equals to negative 2x minus 2. Okay. So very straightforward. Let's go ahead and move forward. Okay, so you guys will get some practice on that. Now, here, for each problem, find dy and change of y given x naught and the differential x equals the delta x. Okay, so again, we're gonna work on 8. So let me scratch this off. So let's go ahead and really kind of take time to process this, right? Again, we're looking at future contexts that are written with as such, and we want to get comfortable. Okay, so we already discussed this portion, right? The differential y is basically differentiate in x with the dx term at the end. Okay, now as far as delta y, this should be familiar to you guys, right? And you can pause the video and ask yourself, what does it essentially mean? Okay. Alright, and if you were thinking, it is basically f of x plus the change of x minus what? F of x. Then you're in the ball game. Okay. Really, with differentials, this relationship between the differential y and the change of y, the differential x and the change of x, just right off the top, they're very much related. Okay, so that's really what differentials allows us to do here, among other things. Yeah. So how are we gonna, for each problem, find dy and change of y, right? How can we compare them? What we need to find them? How do we find them? Let's go ahead and do what we know how to do. Okay. So right out of the gate, let's go ahead and take y equals negative x squared plus 4. Okay, and you want to make an attempt to use the notation as much as possible. Okay, I know we're straying away from that. So what do we have here? We would have negative 2x dx. Okay, so we're not just asked to present it as such. We've literally got to find it given this other information. So let's go ahead and keep going. So we've got negative 2, right? And in this case, we'd have the provided x value is 1, and d of x is 1. So we get negative 2. And we're also asked to find the change in y, or delta y. Okay, so how do we proceed? We can actually pause here and give you a chance to think. How would we proceed? Okay, and if you're thinking this formula here, we're off to a good start. So let's go and do that. F of what? 1 plus 1 minus f of 1, which is going to do what for us? This is basically 2, so we can plug in 2 in here. Okay, so we can negative 2 squared plus 4 minus, I'm just going to plug a 1 in here, so we're going to get negative 1 squared plus 4. Okay. Okay, we get exactly negative 3. Now, as you guys reflect on the objectives for this section, it has everything to do, or in large part, with comparing the value of the differential of y with the change of y. Okay, so here these are basically pretty close, and as you again read this section, you'll realize that the smaller and smaller values you have for delta x, or the differential x, the smaller and smaller values, the closer and closer you get in terms of your value for delta y and the differential y. Okay, very basic, very important moving forward, and then we'll get some additional practice with hospital rule or L'Hopital's rule and some of those differentiation opportunities. Okay, we've got you in class with questions.